All right, so let's look at how unit step deals with inverse Laplace. So again, notice the format of our inverse Laplace here. So e to the negative as times f of s is going to translate into f of t minus a, and then times the unit of t minus a. Okay, so this gives us a way to do some nice conversions here. So we just need to identify certain characteristics. So let's start with a itself. So there we got e to the negative as. So that says that a has to be 2. And then f of s has got to be related to 1 over s minus 4. Okay, so then if we do inverse Laplace of it, okay, so that's just connecting back to how to convert an inverse Laplace with our transformations, and that should give me, that's a transformation of e to the 4t. All right, so that said, let's put that all together with the unit definition there. So f of t minus a, keep in mind f of t minus a is connected to that f of s, so that would give me e to the 4 t minus a, which was 2, times the unit step of t minus 2. Alright, so I kind of felt it helpful to mirror the formula above what we're trying to manipulate here. So e to the negative as, so there we go, e to the negative pi s over 2 tells us that a would have to be pi over 2. And then s over s squared plus 9 is cosine, actually. So f of s is s over s squared plus 9. So if we look at the inverse Laplace of that, we should get a cosine of 3t. Okay. I feel like I'm enjoying color coding today, which is all connected to that. Okay, so let's put up those transformations. So that would give me cosine of 3, and then the t minus a, so t minus pi over 2. And then the unit step, t minus pi halves. Okay, and then like anything in math, there's always other ways to make things slightly more complicated by changing up the routine. So that's just an alternative form of the Laplace transforms we've been looking at with the unit step. Again, this is not inverse, so it's not going to mirror exactly what we just saw, but we can still utilize this format here of the gt unit times t minus a. So in other words, what happens if there's not a uniform transformation in both terms? So what if it's not t minus a for the g and the unit? What if it's just in terms of one of them? We can still make a calculation on that. Okay, so still got to identify what our a is. Probably should figure out what g is, and then look at the transformation of it. So our g of t in this case is going to be our cosine. And so our Laplace transform of cosine is s over s squared plus 1. And that's just going back to our chart on that. And then we need an a. So let's see. So t minus u of t minus a, well, that's obviously pi. Okay, so let's look at, okay, and then g of t plus pi, which is cosine of t plus pi. And that's actually an identity from trig days. We can break that up into addition of cosine formula and simplify that down, but we end up just essentially getting a negative cosine of t on that. Okay, so let's put that all together with our elements here. So the negative comes from the negative cosine t, and then we have our e to the negative pi of s, and then s over s squared plus 1.